Good evening, guys. Good evening, all. Good evening, everyone. Hello, hi, and good evening. Welcome to day two of our Generative AI Masterclass. Good evening. Very good evening, all. Very good evening. Good evening, and yeah, thanks for joining for day two. Keep the same spirit till day 21. Okay, just to make sure, yeah, I'm fine. How are you? So, just to make sure, am I audible and is my screen is visible? Yes, everything is fine. Please use chat box to interact with me. And whenever I ask some help or questions, please respond in chat box. Good evening, or very good evening. Yeah, so before starting our day two, once again, I welcome you all for our day two of our Generative AI Masterclass. Yes, thanks for confirming. Thank you guys. We'll continue with the session. We'll start the session. Okay, fine. So before starting our day two, once again I welcome you all on behalf of pantechelearning. So can we just have a recap of what we have discussed in day one? Okay, before starting day two, let us have a recap. Before 24 hours, we have seen day one of our generative AI masterclass, where we have seen some contents regarding the introduction. Like, for example, we have seen about what is AI, what is the applications of AI in real time, what is the building blocks of AI, and in that we have discussed machine learning, deep learning, computer vision, natural language processing, and so on, and then how they are integrated with products such as the AI applications. And then we have discussed what is generative AI, and this gives the creativity, right? So generative AI is a broader term which has like image based, text based, and image to text based. And I've explained that in this particularly 21 days we will be having image based generative AI contents. So moving towards that, we moved into what are the tools which we require to learn to implement this practically. We have discussed that we need to use Pytorch for building neural networks for deep learning application. We need to learn computer vision. We need to learn deep learning, and then we need to discuss about GANs, like generative adversarial networks. It's a type of deep learning neural network. So moving towards that, yesterday we have discussed about PyTorch, the introduction to PyTorch, the real-time applications which is used by companies like Tesla and ChatGPT, OpenAI, right? And then how to install PyTorch, how to import it, and how to check the version. So I hope this is all the things which we have discussed till now, right? So starting with day two, as we have started with PyTorch, this entire session I'm going to just handle the PyTorch basics. Okay, so it's like very basics, guys, very basics. Yeah, we'll be able to complete in just 21 days. Yeah, so we have PyTorch basics here. So we'll be discussing about what is a tensor, what is the difference between an array and a tensor, and how to create a tensor, what all the options which you have here in PyTorch. Very basic things. If you wonder why we are saying this, because when we go into high-end projects later on after 4 5 days, when we go discussing about deep learning projects, all these simple things will be required for you guys. Okay, so at that time you don't want to get confused. So we are having a particular day in day two for discussing about basics of PyTorch. Okay, so let us start with PyTorch basics. So we are going to discuss and we will be dealing with a lot of tensor. Any idea what is a tensor? And this is PyTorch. Okay, fine. We have already seen that there is another library in the name of TensorFlow. Okay, what is Tensor? What is TensorFlow? Or the library name is TensorFlow. Something related to deep learning, we have something known as Tensor. So, what is Tensor? Any idea what a Tensor is? Anyone have any idea about Tensor? Good evening, guys. Very good evening. Good evening, everyone. Please try to settle before 6. Okay, 6 p.m. We'll be starting our session with a few introduction to what we have discussed in the previous session, and then starting slowly with the contents of the particular session. Yes. So what is a tensor actually? So we'll see some introduction about tensor, because what all you do with Pytorch here, you will be dealing with numbers and they will be represented in the format of tensor. Don't get confused, the simple term. So this tensors are the fundamental data structure used in Pytorch. Okay. Yeah, it may be new for most of the people, don't worry. Okay. Yeah. So tensor are the fundamental data structure. Okay, used in PyTorch to represent data for neural networks. Yeah, Ayush, it has some relation with physics also. Okay. Yeah, you are trying to connect to it. You can understand it soon. Listen. Tensor are the fundamental data structure which is used in PyTorch to represent the data for neural networks. So in PyTorch, we use tensors to encode the input and output of a model, as well as the model's parameters. So what all calculations you do, everything will be represented in the format of tensor, and they can be used to represent images, text, audio, and any other type of data. Everything can be converted into numbers, and they can be represented in the format of tensor. Okay, fine. So what is a tensor then? Okay, see here, in maths or physics you would have learned about what is a scalar and what is a vector and what is a matrix. Okay, not only matrix, we have different dimensions of tensor. We have scalar, which is like a single element, and we have vector, which has multiple elements, and we have matrix, like the 2D, right? So we have all these things. What if this is a single element and this is an array of element? In computation we could tell it as an array of element, right? 1 2 3 comma etc, like a list or a tuple, right? Then we have matrix, which is something like a 2D matrix, which means like inside of a list we can have multiple lists, collection of lists. So that is called as a matrix. So this tensor is nothing but numerical representation in the format of tensor. So you have this scalar, which is like this. It is called as a zero dimension tensor. If you have a one dimension tensor, vector will be a one dimension tensor, and matrix will be 2D tensor, and anything higher than that will be called as a 3D tensor, 4D tensor, and so on. So all these things are tensor. Okay, so you could ask me, guys. Okay, so already we have in programming language in Python we have list. Okay, we have tuple, we have other array or collection of items in the format of array. And also, I don't know how many of you guys know about the library called as NumPy. Have you heard about NumPy? Have you used it, guys? If you are familiar with machine learning and deep learning, you would have used NumPy. NumPy stands for numerical Python. Okay, so it's a library for Python programming for numerical calculations. It does tasks faster compared with your array or your list in your Python. Okay, so we have some faster computation in NumPy. So what's the need of tensor here? So what they are trying to tell is the biggest difference between a NumPy array and a PyTorch tensor is that a PyTorch tensor can run either on CPU or GPU. Okay, so that's the biggest advantage you have with PyTorch as well as with tensor. Okay, the biggest difference between your NumPy array or your Python list is slow compared with NumPy array. NumPy array is faster, nearly 50 times. But when you compare with that, a PyTorch tensor, okay, can either run on CPU or GPU. Okay, so what's a GPU? Like gamers and all would have known about it, right? Anyone have played like GTA 5 or any high end games? You would have, like, if you have your own PC, you would have built-in or additional GPUs, right? Graphics processing unit. It is a chip that you can buy and attach with your PC. So it is a chip that can render graphics for display on an electronic device. Not only that, what's the use here then? So GPUs can perform mathematical calculations at high speed and are used for both professional and personal computing. So they can perform mathematical calculations, they can boost the calculations, because like you are not going to perform some simple addition and like multiplication. You will be having lakhs and lakhs or crores of data. You want to perform all the mathematical tasks, and it takes time, right? So when you have GPU, it can accelerate it. Okay, so this contents, Pytorch tensors are generally stored and processed on the GPU. So they can be speeded up and increase the inference time. Okay, so that's why that's what the advantage. Either you have it in an array or a tensor, they are just numerical representation. But Pytorch tensor can run on GPU, which is really fast, and they can really be helpful. Okay, so that's it about tensor and GPUs. So if you are ready, I could go hands-on to teach you guys about tensor creation. Can we? Is it clear, guys? Till now, we have completed the first 10 minutes of our session. Some introductions for tensor and done all those things. We know how to import torch from PyTorch. So if you are ready, we could go and create a tensor and see what is there. Yes, and how many of you guys used Google Colab yesterday? If you are new, have you set it up everything with installation part and importing? Yes, fine. So we'll go and start with tensor creation. Okay, so first you should go and connect it. Yeah, fine. I hope it's visible. I'll go with import torch. Okay. Okay, torch. Before going in that, we know, right? For example, my list. You could go and create a list in Python. 1, 2, 3. Okay, so this is a collection of items, or you could tell in programming language simply it's array, right? So you could go and check the type of it. For example, type of my list. Okay, so it's a list, and you could also import this package which is called as numpy numerical python, also called as np in short form. So you could go and create an array. Okay, so which is something like this: collection of elements. Okay, collection of items. This is a numpy array. Okay, it looks same, but this does faster tasks compared with your list. Somewhat faster when you have GPU is going to be your torch.tensor. Okay, so inside of it, if I pass a collection of items like a list, it is going to create a tensor. Okay, this is in the format of PyTorch tensor, which can run on GPU and does the tasks faster. But still, we haven't integrated it with the GPU. That I have it in the later part of the session, how to do it. Okay, so for example, I could store it in t equal to torch.tensor. Okay, so t dot d type is going to give you the data type. It belongs to torch int 64. Okay, so the collection of items stored here. So if you ask me which type of array I could create, whether I could go with 0D tensor, whether can I create one dimension tensor or 2D or furthermore than that, you could. For example, see here, this is a 0 dimension tensor with just the element 3, and then I have a collection of items like a one dimension tensor, and then this is in the shape of matrix, right? 1 comma 2, then 3 comma 4. This is a matrix format, which is like a 2D, and then so on. You could go and create like complex tensors. Like these are all simple representations for practice anyway. When we have a real data, we'll be importing and transforming it into tensors so that we can use it in the GPU. Fine, so let me just go and pitch it with torch.tensor 3. So this is a 0 dimension. Here we have created a 1 dimension, and yeah, and torch.tensor. So we could go, for example, a 2 dimension will be having a list inside of a list, 1 comma 2 comma 3 comma 4. Okay, so this will be in the shape of a matrix, and you could have 3D, 4D and so on. No limitations for you. Okay, so we'll just create one more 3D shape. Okay, so we have outer collection, inside of it we have inner collection like this. So that has 1 comma 2, then 3 comma 4. So outside of this particular thing we have 5 comma 6, then 7 comma 8. Okay, so this is what a 3D tensor will look like. Okay, so it's a collection of two dimension or two matrix inside of it. You could tell it in that way. Yes, it processes tiny packet in larger size. Very good, Vinod Kumar. So we have some methods here inside of our tensor. Okay, so once you create a tensor, see here, I'm going to assign this tensor 5 comma 6 to my variable which is t. Okay, so once I have created it, I'm going to just use my option which is called as n dimension. So this guy is going to tell you what's the dimension you have in that particular tensor. Okay, so if you are confused, you could just go and click that. For example, so let me just store this particular thing t equal to this particular data tensor, and I'm going to go with t dot n dimension, and it's just going to return me 3 because this is a 3 dimension. Okay, so if I store x equal to this 2d, if I go with x dot n dimension, these are some methods. Okay, this is 2, this is a 2 dimension, right? Clear? So this n dimension is going to give you the dimension which you have in that particular data. So this will be really important when you have your own data set, when you convert it into a tensor. What it does is, sometimes when we go and perform numerical calculations, when we build neural networks, if the size mismatches, you are going to get obviously a lot of errors. In such case, you need to learn once again. Okay, so you will be discussing about the shape of it, you will be finding it and then sorting it down. So in such case, these n dimension and further steps which you are going to see will be really helpful. Yeah. So next is going to be shape. Okay. So this is really important. This is the exact part where you can sort a lot of error which you will be facing between like when you create a neural network. So I'm going to go with t dot shape. So let us go and check it how to find it. So in t, I hope we have 3 dimension tensor. So I'll go with t dot shape. Okay. So we have 2 comma 2 comma 2. So what is that? Any idea? Okay, so we have one dimension, sorry, two dimension. So that's the outer size. Inside of it we have two one dimension, and inside of that we have two elements. So if you are confused, what I could do is I could add one more element in all of these things. Okay, so this will show you the difference exactly. So this is the shape. Now if I go with shape, I should get 2 comma 2 comma 3, which tells that two outer dimensions. Inside of it we have two one dimension array, and inside of that we have three elements. That's the shape. So like that, if you go with x, can you guys predict what the shape of x will be? If I go with x dot shape here, so we have a tensor which looks like this, which is a 2D tensor. This is the exact thing which is inside of your x. What will be the shape of x? Please post down in chat box. Okay, tensor is just a numerical representation. It's one of the basic data structure in Pytorch. Okay, so they are numerical representations. But what's the difference between your NumPy array and your Pytorch tensor is NumPy array can only run in your CPU, but when you go with Pytorch tensor, okay, so they can be run with the help of either CPU as well as GPU. So if you have GPU, they can perform the task really faster. That's the difference. Very good, guys. The shape is 2 cross 2. Okay, 2 comma 2 will be the shape, which tells that you could take it as a 2 row 2 column, or you could find that it is splitted into two one dimension, and inside of that we have two elements. Okay, so now if I have this, what will be the shape of it? If everyone is posting correct answers for this, we could go on to the next one. I hope that will be make everything clear. Now what will be the shape of my x? What will be the shape, guys? Very good, very good. Many are posting down answers in chat box. Can you guys post down answers for this? The shape of X? Waiting for your response. Yeah, 3 cross 2, 3 comma 2 will be the shape of it. Okay, because it is splitted into three one dimension, and instead of that we have two elements in each. Okay, so that's the shape, which shape is really important thing when you go and implement practically. It will help you to decode a lot of process inside of it. Fine. Now we are going to start with random tensors. Okay. If I tell you, what if I tell you guys, deep learning is just like it will just start with a random number. Okay. Tomorrow session will be really important and interesting as well, because tomorrow session I'll be discussing about the basics of deep learning. Okay. So there I'll tell you how a neural network works. Just a glimpse I'll tell you. Neural network starts with a random number, just a random numbers, and then it tries to adjust that random number so that it mimics, or it tries to converge with your original data. It tries to learn. That's how it learns. It's learning like a children. Whenever a child is starting to write, for example, in their own mother tongue, they will be writing the letters once again, right? So when they try to write first time, they'll write some random things, but over the time, okay, someone will teach for them and they'll try to perfect it. So nowadays we are writing everything very perfect, right? So that's how a neural network also learns. So this randomness, okay, so the random, you could also get random numbers. So you could go with torch.rand, okay, and everything now from now on, whatever you create, the data type they used to have, they belong to tensor, okay. So and nothing will coming inside of it. We will be having data type, particularly whether they belong to int or float, but they belong to tensor. So this rand will give you random numbers, and this parameter you are going to pass is the size. If I go with 3 comma 4, I'll be getting a matrix with 3 comma 4 or 3 cross 4 with that particular random values inside of it. So let us go with torch.rand. Let me just go with 4 comma 4 or 3 comma 3. What am I getting, guys? Okay, so I'm getting some numbers, some random numbers in the shape of 3 comma 3, right? So if I go once again, I'll be getting different numbers, random float values. Okay, very good. 3 row 4 column random values. Here when I go with 3 comma 3, I'll be getting 3 row 3 column random values. Okay, so every time I rerun, I'll be getting different values in that particular shape. If you want another dimension you want to add, you could just go with 3 comma 3 comma 2. So what will be having, we will be having 3 1 2 dimension inside of it, 3 1 dimension inside of it, 2 elements. Okay, so if you want, you could store it and check the shape of it. Understood how we are using rand to generate random numbers? Understood? Can we continue, guys? You could also pass this as size. Okay, so this particular thing we are passing is nothing but size. You could directly pass the number, or you could just pass size equal to. So when you go with that, make it as a tuple. Okay, so this is the exact thing which you could go. Okay, what's the difference between Pytorch and Jupyter Notebook? Pytorch is a Python library or framework for deep learning, and Jupyter Notebook is an IDE like our Google Colab. They two are completely different things, but integrally they will be used. So, for example, if I want to create an image, most of the time, like from after a few days when we discuss about computer vision, the image will be in the shape something like the height and weight, for example, 224 comma 224 with 3 channels. So if you want to create, the image will look like this. Okay, so it's a big one, 224 dimension, inside of that 224 one dimension, inside of that we have 3 elements inside of it. Okay, so this is how you will like twist and get the random shape with the size which you want. Okay, and guys, 1 minute. So you can join this as an internship user. So if you find this interesting, this generative AI masterclass, you can join as an internship user and convert this masterclass into a 1 month certified internship on generative AI. So what are the benefits you will be getting once you join? So you will be having 30 days of live sessions. From this 21, you will be having additional contents on basics of machine learning. So totally it will be a 30-day, 1 month internship. You will be getting 90 days of access to those records, source codes of projects. You will be having generative AI as well as machine learning projects. All the data sets, code files, downloadables will be given to you in the downloadables. You can get all the PPTs. You will be also getting 6 mentor live Zoom sessions. Every week we'll be having one session where you can join in Zoom and directly interact with me to clarify all your doubt. You will be having internship confirmation letter once you join, and you will be having internship certification. Once you complete this internship, you will be getting certification on generative AI. So to avail all these benefits, you can join as an internship user, and the fee for it is a discounted fee of 899. The link is posted in the chat box. You could find the registration links in chat box. If you are interested, you could use it. And once you join this internship, you could avail all these things, the topics which you are covering, the downloadables, the code files, especially from day 11 to 21, we have generative AI contents, image generation, and a lot of interesting codes. All these files, downloadables, will be given to you, and you will be certified in generative AI. It is really an upcoming skill, and this will make you stand from everyone else who are an AI. Okay, so the link is given in chat box. I hope we can continue with the session on random tensors is fine. What's the use of pandas in Python? Pandas is used to handle CSV files, to work with that data set, to pre-process it, to handle the data. All those things can be done with pandas. For machine learning basics, you need to learn pandas. Yes, it's possible to change between CPU or GPU if you have GPU. Later on in this session, I have contents for how to switch to GPU. Now I have created some tensor, right? They are not in GPU, they are in CPU only. But how to turn it into GPU, I have it in the later part of the session. So please wait. So we need to go step by step, right? I hope we can continue with zeros. Okay, so we have torch dot zeros. So you can pass a size. So what it does is it is just going to create zeros in that particular shape. These are tensors in the format of zeros, and there is a really useful need. Do you? How many of you know, guys, the basics of computer vision? The basics of computer vision. Can you guys tell me if the image is completely black, what will be the numerical value of that image? If you want to learn pandas in machine learning basics in this one month internship along with generative AI we are giving, so you could join in the internship. In this 21 days, it's not possible. You can have it in that internship, or you could check our site. We have specific courses on pandas as well as NumPy. Zero will be black, right? So in such cases, when we need to create black images, we could go with torch.zeros. So let me pass the shape of 4 comma 2. Okay, so 4 comma 2 only zeros. Okay, so that's what zeros are. And then if you want completely white image, what will be the number? It will be 1, right? So in such case, torch dot ones. So you could go with the specific size, and you will be getting that particular ones. Let us go with 3 comma 4. Okay, so completely ones. Internship, you will be getting LMS portal, so it is already going on from yesterday. So you will be having the recorded sessions you could watch, and you could download the downloadables from every videos. And every weekend we will be having a separate WhatsApp group for the internship users. We will be having Zoom sessions. The particular day will be announced, so you could join and you could clarify all your doubts. Voice breaking. Let me check. I hope it's fine. The signals are proper. Am I audible, guys? Yeah. So going with range in Python, we have range, right? Similarly, if you want tensor, you want to create a range of elements, you could go with torch.range. Okay, in this first 21 days, if you join, you will be getting it in the discounted fee of 899. Otherwise, you will be having like the original fee. Yeah, fine. So going with torch.arange, which will give you a range of elements. So let me just go and create torch.arange. Okay, so let us go from 2. What's the ending step? Which means that when you end, it will give you one step before. For example, if I go with 11, I'll be getting from 2 to 10. Okay, so it's similar to Python range from 2 to 10. Okay, so if you want, you could go with 100. So you will be having that particular range with one step. So if you want to have a step, you could have a third parameter which is step. For example, I want a step of 10, which means I'll be getting 2, then 20, and so on. Sorry, 2, 12, then 22, 32, 10 steps next. Okay, so like that you could use it for creating range of elements. Yeah, this is interesting one. Zeros like. Okay, so what is this zeros like are? So let us go and try. For example, let me just go with t equal to this particular one, and let me go with torch dot zeros like, and I'll pass t. So what happens is it is just going to give me zeros in whatever shape I am going to pass. Okay. For example, if I pass this in this shape, I'll be getting this. For example, if I have this ones, okay, I'll store it in t in the 3 comma 4 format, right? So if you go with zeros like, you will be getting in that particular shape all zeros. Okay, clear guys? So that's zeros like, and D type I have already used it, so let me show you once again. So if you want to check, okay, for example, in T I have this tensor, right? So if I want to check the data type of it, I could go with T dot D type. So this belongs to float 32. Okay. So if you want to create in some other data type, you could go with, for example, okay, we have torch dot rand. I'll go with the shape of 4 comma 4, and then I could go and mention what the data type I want. Okay, so I could go with torch dot float 16. Okay, and if I go with t, the values will be there. Okay, and they belong to the data type of float 16. So you could go and verify it with t dot d type. Okay, so like that you could twist and play with data types if you want, and yeah. So now we move into some mathematical operations with your tensor. Okay, so they are array, collection of element. You could play with those. For example, let me just create a basic one-dimension tensor with t equal to torch dot tensor 1 2 3 4. Okay, so let us go and play with t plus 10. What will be the output? I'll be getting 10 added to all the elements inside of it, right? Then t minus 10 subtracted, then multiplied. So you could do this part. Okay, so this is mathematical operations, very simple, but some more else are available. What if we do some element wise multiplication? For example, I have two different tensors and I am going to perform some multiplication between them. So let me just go and create another one. T2 equal to torch dot tensor 5, 6, 7 and 8. Okay. So T multiplied by T2. Okay, so what am I getting? The multiplied element wise multiplication with that size, particular size. What if I have something like this? I can't go and get the output properly. So If you want to perform this between two different matrices, their size should be equal, then only they can proceed with that. Okay, so you could also go with torch.rand 3 comma 4, and I could go with torch.rand 3 comma 4. Okay, so now both are in same size. If I go and multiply it, I'll be getting answers. Okay, so element wise multiplication, and this is what we'll be using in lot of deep learning purposes. Matrix multiplication, in short form we have an option which is called as matmul, matrix multiplication. So what's the use of this? So let us see about matmul. Okay, so this is a matrix multiplication. So if I go and perform this, okay, so first let me do it. If I do it here in my t and t2 which I have now, I'll be getting surely error. So let me just show you what is t. What is T2? See, they both are in same shape. So I am going to use torch.matmul, okay, T comma T2, and ready to get error. Yeah, so the error is this shape 3 cross 4 and 3 cross 4 cannot be multiplied. Okay, so when we does element wise operation, it was really fine when we have the same shape. But if you want to perform matrix multiplication, then what need to happen is the inner shape should match. This 4 and 3 shouldn't, they are not same, right? You can't perform this. If you want to perform matrix multiplication, then this inner shape, this 4 or this 3, they both need to be same. Okay, so the output what will be, will try. For example, here I am going to just twist it as 4 comma 3. Now the inner shape is same. The outer shape doesn't matter. For example, I will go with 4 comma 6 also. Let me just go and multiply with t. This is t2. If I go and perform matrix multiplication, I will be getting the answers. Okay. So what that particular answer is? Can you guys find what's the shape of this? Let me just go with t dot shape, which is 3 comma 4, and t2 dot shape. Okay, this is 4 comma 6. So what's the output shape is? T3 equal to T3 dot shape. Okay, 3 comma 6. So what's my output is? Can you guys see what is happening here? So when the inner size matches, my size and shape here are 3 comma 4, 4 comma 6. So when this 4 and particular 4 matches, you can perform this multiplication and the output will be in the shape of this outer elements, which is 3 comma 6. 3 comma 6, same, right? So that's how matrix multiplication works. Okay, so this is used in a lot of places. That's what matrix multiplication is. Using matmul, the inner dimension should match and the output will be in the shape of outer dimension. So here if you perform, your output will be 2 cross 2 matrix in the output. And we'll see some basic operations like min for minimal value in that particular, max for finding the maximum value, mean for finding the average, sum for finding their sum, and argmax is really an important one when we go for predictions. Argmax will give you what's the index number of the maximum value. Here the maximum value is 23. From Python we know the indexing starts from 0, right? So this is 0th element, this is first, this is second. Here the output for argmax will be 2 because in the second index we have the largest element. Okay, let me just show you with a simple example. Okay, so let me just go with t dot min, t dot max, check whether it's correct or wrong, t dot sum, t dot mean. Okay, mean. Okay, I look into it for mean. Then t dot argmax. Okay, so the tensor 4, whether 4 is the biggest one. Okay, so we will be having the index which is 4, 0, 1, 2, 3, and 4, 120. Good question. What if we have two elements having same highest number? So let me just have 120 here also. Okay, so let me just go with argmax. Okay, so what happens is your interpreter starts from left side until goes till your right side. So whenever it finds one largest, okay, so what it does is it takes the first one or the first entry. Okay, so every time you run, you will be getting two. So if you have another entry which is here in the zeroth index itself, zero will be there in your output. Okay, so that's how if you have multiple elements having same highest number or max works. Yeah, so now going into another parts like reshape. Okay, so this reshape will be possible if the conditions are working, then the reshape will be fine. Okay, so let me go with t equal to torch dot rand 2 comma 4. Okay, so let me just show you t. Okay, it's 2 rows and 4 columns. So if you want to reshape it, okay, if possible it will work. For example, I could go and use reshape and I want to pass a parameter which is the shape. So now you have 8 elements with you. Okay, so in between totally you have 8. So if you want you could split it as 4 comma 2, which means 4 row and 2 column. It's possible. Okay, but what if you try to go and split 4 comma 3? Error. Okay, it will be invalid because the size is 8, they can't be matching. Okay, so you could go with 4 comma 2, or let us try 2 comma 2 comma 3. Okay, so they are not possible. 2 comma 2 comma 2 is possible, right? So like that, whenever you go with the proper size or proper parameters, you could go and reshape it. So whenever required, you could reshape it. Okay. Yeah, so before going into view, once again, so if you want to convert this masterclass into a certified internship on generative AI, the link is provided in the chat box, it is pinned. So you could join as an internship user and you will be getting the benefits of 30-day videos, access to it for 90 days, source codes of projects, downloadable PPTs, Zoom session, and internship confirmation and internship certification. So this internship on generative AI really will be a boost for your career. And yeah, so you could join as an internship user, and if you do it in this 21 days, you can get it in a discounted fee of 899. The link is posted in the chat box. And these are all the topics and the projects we'll be having: image generations using different GANs, face generations of like which looks similar to original one we will be creating. Yeah. So continuing with view torch.rand. So yeah, we'll go and see what is views. So I have a T. Okay, so this is in the shape of 2 comma 4. Okay, so I could go and create a view which is t dot view. Okay, so view is nothing but it will store the same values, but you could reshape it and store it in another variable. Okay, you could have the same values, but you could reshape it and store it in a new variable. For example, let me just store it as 4 comma 2. Okay, so now this view, if I have in v, let us see. Okay, so this is the same values, I have it in different shape. Okay, so what's the use of this? Let me tell you, they have the same memory allocation. Okay, so if you change the t, the v value will also change. So let me do it hands on. T of 0 will give me the index. Based on indexing, I'll be getting the first one dimension. So in that particular 0, if I get, I'll be getting this 0.694. So let me assign this as 0.3. Okay, so I'm going to assign new values to it. So now if we check t, okay, see here now it's 0.3000. So if you go with v, so let me run it. Even though I haven't run this, see here, whenever I change t, the view will also get changed, but the size and shape will be different here. That's the interesting thing about view. So you could take a copy with a different shape, you could view it and use it. The values will remain same. So if you adjust original one, since they share the same memory allocation, your view will also get changed. Okay. Fine. So next we are going to discuss about stack. Okay. So let us start with stack. So stack is like arranging or combining different tensors or arrays. So let us go and create two arrays of tensors. So t equal to torch dot tensor, t2 equal to torch dot tensor, and let me just go and stack them with torch dot stack t comma t2. So when I stack them, what happens is when you have two different tensors, okay, yeah, it has a lot of parameters which look same like NumPy, but still this can be ran on GPU. Some additional properties are also available. We'll see. So this stack will help you to combine them or stack them. See here, I have two different one dimension. Now I have combined into a two dimension, right? So you could also use a parameter which is the axis of stacking. So if you go with the axis of 0, the same result will be obtained. But if you go with the axis of 1, then you will be getting this particular result where one dimensional stacking will be done. See here, 1 comma 5, then 2 comma 6, 3 comma 7, and 4 comma 8. Yeah, creating a 2D array. Clear? And then we have a parameter which is called as squeeze, and this squeeze will help you to squeeze the element, which is nothing but if you have an element which is like inside of it you have a one dimension and you have an additional dimension like this. See here, we have only one element inside of the 2D. So if you want to remove this additional dimension, you could go with squeeze. So that will help you to remove that. Let me show you. Let me just pick this entire thing, copy it, paste it here with adding another dimension. Okay, so let me just show you guys what t is. Yeah, so I have an additional dimension now. So if I want to remove it, I could go with torch dot squeeze and pass t inside of it. So that additional dimension will now be removed, and I'll be getting the output of it. Okay, so if you want, you could store it in a result of t equal to this. Okay, so now my t will be removed one, but if I want to add, okay, so if I want to add another dimension to it, what I could do is I could go with torch dot unsqueeze and add t, and then I need to pass a dimension, which is the dimension here is 0. I want to add in the 0 dimension. So this is what, when you unsqueeze it by adding another dimension, you can interchange this. Okay, clear guys? Is it clear? Yeah, this is what we have seen now. Unsqueeze. Please wait for furthermore 10 minutes because we have some contents left. Few more slides. Permute is really an important thing whenever we go with image-based tasks like convolution neural network and all. You will be getting this exact mismatch errors. Okay, sometimes the neural network requires the number of channels at first and then the image parameters later, or you want it in mismatch. So let me show you an example what this permute will help you to do. Okay, it's really important for image-based tasks. So let me go with t equal to torch.ran. Okay, so let me pass a shape of 2 to 4, comma 2 to 4, and then 3 image channels later, and then, okay, so let me just pass this and let us go with t. Okay, so we have this shape. So if you go and check the shape, it will be 2 to 4, 2 to 4, and 3. So what if you want to reshape where this 3 dimension should be coming in the first, which means instead of having 224 2 dimensions, you want to have 3 2 dimension, then inside of it 224 1 dimension, inside of it 224 elements. So you could do it with t dot permute. Okay, sorry, it is torch dot permute or yeah, t dot permute, where I'm going to pass a parameter. So what is the dimensions I want to change? What is the order? So I want to have my two dimension, which is this is 0, this is 1 and 2. Okay, so this second index should be coming first. So I need to pass 2 comma. So should I want to change 0 and 1? So I want to have it in this format of 0 and 1 should be coming later. 2 should come first. So if I go and run this, I'll be getting this particular thing. Okay. So if you just go and check their shape, you will be having 3 comma 2 to 4 comma 2 to 4. Okay. So that's what the permute will help you to do. Okay. Clear? What if the dimension is 1? Okay. So maybe in 2D we could have it. Okay. Now the T is different one, right? So let me just go with T, squeeze it. Let us use a T and let us go with the dimension 1. This is what the dimension 1 is. Understood? Adding extra dimensions in the column wise or inside a 1D in the elements, you will be having this clear about dimension 1. I'll try to sort all the doubts here. So if you want particularly you want to solve all your particular doubts, I'll suggest you to join the internship. But this is a live session. I could handle few doubts in the live as well as I need to take classes, right? So most of the times, okay, you will be dealing with NumPy and then Pytorch and so on. So what if you have your data in NumPy format in a NumPy array and how to use it or turn it into a Pytorch tensor? You have an option called as torch.from NumPy. Okay, so if you pass a NumPy array, it can take from NumPy and convert into a Pytorch tensor. So let us go and utilize the NumPy I have created np.array. Okay, so I could go with torch dot from underscore numpy and pass n here. Okay, so this is now turned into a tensor with same values. Okay, and what if you have done your task with PyTorch? You want to convert it back to numpy. Okay, in numpy array format. So you could just call dot numpy to turn it into a numpy array. For example, I hope in T I have a tensor, right? So I could go with t dot numpy to turn it into a numpy array. Okay, see here, it belongs to numpy array. Okay, yeah, few more things. Manual seed. So I hope you guys seen that we have used the random numbers, right? So we could go and call this manual seed, but what's the use of it is? We have randomness, and if you want to have similarity and if you want to have reproducibility, you could use this manual seed. It will like pick a particular randomness, and if you apply it, you can get same values. Okay, in random you will be getting some different values, right? If you want to mimic the same values, you could go and set a manual seed with seed value with torch.manual seed. Okay, so you could set a seed value as, for example, let me set it to any value. I'll go with 42. Usually it is set. Okay, so I could go and create torch dot rand and let me pass a shape of 3 comma 4. Okay, so I have these values, right? So what if I go and use torch dot rand 3 comma 4? So I'll be getting different values now. Okay, see here different values. So what if you want to have the same values, the same randomness, what you could do is you could just do the same seed number. So if you go and call the same seed number, so you will be having the same values exactly in that particular seed. Okay, so if you want this IPYNB, you could join as an internship user. This all code and IPYNB data PPTs will be given to you in downloadables. The link is posted in chat box. So that's what manual seed will help you to do. Okay, so talking about device, can we see about device and wind up this session? Can you guys be patient? So if you have NVIDIA device and if you have a GPU, you could check it with this with exclamatory mark in command line interface NVIDIA SMI. Okay, so you could check it. It will tell you if you don't have your GPU and if it doesn't configure, okay, so you can't have it here. So in Google Colab, how to avail this GPU? So if you want, you have to go and click this arrow, okay, and you can click this change runtime type. Okay, so where you can use this T4 GPU for some time. Okay, so they are giving it free, so you can use it for free for a few hours. So you could click it. So if you save it, your runtime will be changed. It will reconnect and everything you have done. The memory will be gone. The code will be there. You want to rerun it again. So now you could see that it is connected to GPU from Google. Okay, from Google Colab. So what you could do is if you run and check NVIDIA SMI, you will be getting what's your configuration you got. Okay, so this is a CUDA version. You have a GPU integrated. So likewise, you could avail GPU from Google Colab. This is how you could go and select the runtime type where you could select this GPU. So apart from that, if you want to utilize it, not only this, if you want to utilize, you could check first whether it's available or not. Okay, so to do that, you could go with torch.cuda.is underscore available. Let me do it. Torch.cuda.is underscore available. Okay, since we have restarted this session with GPU, we need to import torch once again. Okay, so true, which means that it is available. Okay, so CUDA version is here, it's 12.2. It's from Tesla, actually, Tesla T4. So the CUDA is available. So what you could do is you could create a conditional statement in Python. CUDA if torch is available, if it's true, have the device value as CUDA, or if not, else go with CPU. So let me just type it. Device is a variable we will be using in lot of times. CUDA is the command to use GPU. Okay, CUDA if torch.cuda. If you have it, you will be getting true. Okay, is underscore available. If the result is true, then go with CUDA. Else, just pass CPU. Okay. So now, if it's true, if I have GPU, I'll be having the device as true. If you don't have, just try it. You will be getting CPU. Okay. So now I have a variable which has a string name CUDA. So how to use it with GPU? So if you want to connect it, okay, to your numerical variables for your model and all, you need to call dot to and connect to your device or pass CUDA there. Okay, so let me just show you. First, let us go and check our T. Okay, T and all we haven't created, right? So torch dot rand T comma 4. So this is T, and if you check T dot device, it is going to tell you it belongs to CPU. Device object is not callable actually, so you could go and call device. It belongs to CPU. Okay, so initially the tensors will belong to CPU. They can run on CPU as well as GPU. But if you want to connect it to GPU, you could go with T.2 and you could pass this device which is having CUDA now. If it's available, now it will be transformed. And now see here the device is now CUDA. Okay, so you could just store T equal to 2 device, and if you go and check t dot device, you will be having it in the GPU, okay, which is CUDA. And if you have multiple things like this, when we go, we will be integrating every numerical features, inputs and outputs and model parameters to device, which is GPU, so that they can run faster and perform faster calculations. So that's it about the basics of PyTorch. A lot of things we have seen which may be confusing. Try to rewatch or learn once more this again and do it a practical session. You can understand it very well. And don't worry when we go hands on and building parameters and building neural networks. We'll be using all these simple things and you can be thorough when we do that later on. Okay. So in day 3, tomorrow is going to be a fully theoretical session on what is deep learning and what is neural network, how it works. The maths behind it will be dealt in day 3. So you could join day 3 tomorrow. So we'll see you tomorrow. Thank you. Thanks for staying till this time, not leaving once you got the attendance link. Very good. And I appreciate and I want you guys to continue this spread for the next of the days. I hope this session was fine. We have dealt with a lot of basic things. It may be new. It's very simple. I have tried to show everything practically. You want to practice so that you can be thorough in it. Thank you. Thank you all. And once again, so if you want, you could join as an internship user, convert this as an internship. You could use this QR code or you could use the link which is provided in the chat box and get it in a discounted fee of 899. Thank you.